How to solve systems of equations without graphing using substitution. We will do two examples together. The first one, we have a system that says 2x minus 3x is equal to negative 3, and x minus y is equal to 1. We will solve this. We will need to solve for both x and y. So we have two equations and two variables, so we can solve this. What we will do is we will substitute x or y in one of the equations. So first, we need to solve for either x or y. So in the first equation, because we have coefficients of 2 and negative 3, it makes it more difficult to solve and get x and y by itself. In the second equation, it is very easy to get either x or y by itself. It doesn't matter which one we get by itself, but I see if I rewrite this, I have x minus y is equal to 1. I can add y to both sides, and I easily get that x is equal to 1 plus y. So I have solved for x. Since I have easily solved for x, now I can plug this in or substitute it in for x in the second equation. So if I do that, I have 2, and then instead of putting in x, I'm going to put in 1 plus y, because that is what x is equal to. So I'm going to write that in parentheses, 2 times 1 plus y minus 3y is equal to negative 3. So I have substituted x with 1 plus y because I solved for x from the second equation. Now my equation only has y's in it, so I can solve. So first thing I have to do is distribute. So I have 2 times 1 is 2, plus 2 times y is 2y, minus 3y is equal to negative 3. Now I'm going to combine like terms. So I have 2y minus 3y are like terms. That combines to negative 1y, or I can just write it as negative y. And I'm left with 2 plus negative y, or I can write it as 2 minus y, is equal to negative 3. Now I'm going to subtract 2 from both sides to help me get y by itself. So I'm going to be left with negative y is equal to, well, negative 3 minus 2 is negative 5. And since I have negatives on both sides, I can divide by negative 1 on both sides or multiply by negative 1 on both sides, and I would end up with y is simply equal to 5. That's getting rid of the negative sign on both sides. So I get y is equal to 5. So I'm not done. I've solved for y, but I don't know what x is. So now that I know what y is, the easiest thing to do is plug that right into my original equation where I know that x is equal to 1 plus y. So since y is 5, x is equal to 1 plus 5. So x is equal to 6. So I have my x coordinate is 6 and my y coordinate is 5. I get that my solution should be 6, 5. And that would be my solution to this system of equations. That is the point where they intersect. So we can check if this is our right answer by plugging this into a graphing calculator. So I have 2x minus 3y equals negative 3. I am going to plug that into desmos.com/calculator. So that was 2x minus 3y is equal to negative 3. And my other equation was x minus y is equal to 1. So plug that in, x minus y is equal to 1. So they have both been graphed, and I can see where they intersect is at 6, 5. X is 6, y is 5. So we see we've gotten the correct answer. Let's do one more example together. Here we have 3x plus y is equal to 5, and 5x minus 4y is equal to negative 3. We have two equations, two variables. We want to solve for x and y. We're going to use substitution, so we need to solve for either x or y. It looks that in the first equation, it's very simple to solve for y, since y has no coefficient. So we are going to rewrite the first equation, and we are going to solve for y. I want y by itself, so I need to get rid of this 3x, so I have to subtract the 3x from both sides. It cancels out. I'm left with y is equal to 5 minus 3x. So I have solved for y. So now I can substitute that in to the second equation. So I'm going to rewrite the second equation. I have 5 times x minus 4 times, instead of y, I'm going to put in what y is equal to. 5 minus 3x is equal to negative 3. Now I'm going to simplify this equation by distributing. So I have negative 4 times 5 is negative 20. And negative 4 times negative 3x is positive 12x. And I still have the 5x, and I still have the negative 3. Now I can combine like terms. I have 5x and 12x is 17x minus 20 is equal to negative 3. I'm going to add 20 to both sides. So I get 17x is equal to, well, negative 3 plus 20 is 17. So if I divide both sides by 17, I get that x is equal to 1. So now that I have what x is equal to, I can plug that in here to get y. So y is equal to 5 minus 3x. Y is equal to 5 minus 3, and x is equal to 1, so 3 times 1. Y is equal to 5 minus 3, and y is equal to 2. I get y is equal to 2. So my ordered pair, the point where these two lines intersect, is at 1, 2. X is 1, y is 2. And you guys can check that using your graphing calculator. So that is our two examples on how to solve systems of equations using substitution.